Hi educators, I'm excited to share another Patchr lesson with you, and this one is called Solar Lantern. So in the Solar Lantern lesson, we're challenged to create a printed circuit board or PCB that uses the renewable energy created using solar panels to make a rechargeable lantern. This activity will challenge your students to go beyond the basics of prototyping circuits as they create their own unique hardware solutions. As always, there are endless things that your students can create, but through Patchr's unique design interface and instructional resources, students of all learning levels will be able to find success throughout this lesson. Let's get started. After launching the Solar Lantern lesson through Patchr.io, we are guided through the fundamentals of how the circuit actually works by learning about conductors, insulators, and semiconductors, as well as photovoltaics and solar panels. This lesson creates real-world connections for students as we learn about sustainability and how our circuit can create clean and renewable energy just from light provided by the sun. As always, we're guided through the stages of this lesson through the Patchr co-teacher known as Squidly. Squidly just keeps us on track, encourages us to keep going, and lets us know when we may have run into a problem with our design. For the PCB board, you are provided with a sample shape that you're able to use throughout the lesson, but you can also draw your own board shape right in the Patchr Design Studio, or even import a vector outline in SVG format that can act as your shape. These types of shapes and board designs can be created in a lot of different programs that are suitable for students of all levels like Tinkercad, Google Drawings, or Inkscape. It's up to the educator to decide the detailed constraints of the lesson, but we love to see students design their own custom board shapes as an extension and additional challenge for this activity. In the next stage of the lesson, we're guided through placing our components onto the PCB board. For the Solar Lantern lesson, this includes key components to make the circuit function properly, like our resistors, diodes, LEDs, a transistor, as well as the controlling systems like the switches and JST connectors. What these components do and how they work are described in much greater detail throughout the lesson, as well as the Patchr Learning Library. This library can be referenced right from the design interface. As we lay out our board, a ghosted image helps us ensure that the components aren't too close to the edge of our board or overlapping, as this could cause potential problems in the manufacturing stages. But don't worry, Squidly always checks our progress and will let us know if we made any mistakes, and this goes for custom PCB board shapes as well. We then need to create the circuit by routing the paths between the different components using the tracing tool. There's usually more than one correct way to route a path, but these guidelines can be used to help ensure that we find success in this crucial stage of the design process. While Patchr's design software offers the sample ghosted image and the path routes, they do not need to be used. They're there to support new learners as they place their components and create their connections, but students can open up the design process and lay out their components uniquely to however they want to design their own custom board in this lesson as well. Lastly, we have the chance to customize our board through unique graphics and designs in our silkscreen layer. Students can add their names or the title of a project or even a personalized design to enhance their PCB creations. Once done, we finish our board and send it to fabrication. You will then receive your own custom PCBs in a unique kit that includes everything you need to assemble your circuit per student design. This also includes assembly instructions which walk students through each step of the process. Each kit and assembly guide is customized and unique to each student based on their design. Now, to assemble our lanterns, we need to solder our components together. Soldering is the process of joining two metals together using a filler metal, which we call solder. We use soldering to create connections between a lot of things, but most commonly to create connections in electronic circuits. Soldering is a really important skill if we want to learn how to create our own custom electronics, and students will gain a lot of experience in soldering through the Solar Lantern lesson as we solder our own custom circuit boards together. For students who are entirely new to soldering, we recommend checking out our Learn to Solder resource guide and introductory design challenge, as well as referencing the assembly guide provided with each Solar Lantern lesson. As we assemble our lantern components, it's important to keep track of which components are polar. Polar components such as the JST connector and LED have a positive and negative connection. If we do not connect these polar components correctly on our PCB board, the current will not be able to flow through our components in the right way, and therefore our circuit won't be able to work correctly. The assembly guide will walk students through this stage of the process, ensuring that the components are installed correctly. But we can also look at the pad shapes on our PCB. Square pads are typically used for negative connections, while round pads are typically used for positive connections or for components that are non-polar, such as our resistor and switches. Once assembled, we can test out our circuit. We can connect the solar panel and the battery pack using the correct JST connection ports that we just soldered onto our PCB board. The battery pack needs rechargeable AAA batteries in order to function, and we can turn on the battery pack using the power switch on the actual pack itself. We can then test out our circuit with our 2 soldered switches. Switch 1 is an on-off switch, but even if the switch is off, the solar panel is still able to charge the batteries as long as it's in the sun. Switch 2 allows us to change the brightness of our lantern with either 1 LED on or 2. The switch on the battery pack acts as a main power switch, but if this one is off, the panel cannot charge the batteries, unlike switch 1 on the PCB board. Pretty cool, right? But the lesson doesn't need to stop there. There are endless possibilities for this project. The students are not only challenged to create their own custom circuit boards, but also prototypes and hardware solutions around them. We love to incorporate topics of empathy and sustainability with our lessons. Creating solar-powered lanterns using recycled materials or craft supplies to add ergonomic and aesthetics can empower students to create truly amazing things. Visit us at patchr.io and start creating your own custom electronics today.